I did that. I need one student of course, que attending every day, no? And or remind me, or you try to do by yourself. Okay, you click. You know where you recording in the bottom, in the lower left corner. You see one button that says stop or recording. No, you click here and I have recorded. I don't know why I forgot always. Is the board now? You set one first set. Que normally is called domain. This is the technical name. Okay, and we have a second set. It's called range. And the relation is some association between set 1 and set 2. Association means that you select element, items inside the set. Remember, set is just collection of the object. Maybe number, maybe letter, maybe people, maybe a student, object in general. For example, to understand this, suppose domain is the set formed by students, hypothetical students. Sally. Entonces, normally in the set, it doesn't matter the order. No repetition is necessary. What happened, Junior? Sally. I just clicking record, professor. No, I did that. Thank you, Minerva. Paul. This is students. In one class, hypothetical class, how they call it algebra. King and Luis. This is the domain, is the set number 1. And now I want to associate relation. Relation is association between two sets. And the range is the, the possible grade that we get in MAC1105, It's A, B, C, D, or F. Okay, this is the potential grade. I suppose que no student in my class now, and the for 2020 get D or F, I suppose. Okay, entonces the record, the association, so the relation, E. The relation is the association. I see you, but not the board. Why not the board? Everyone saw the board, yes or no?
Yes.
What's the problem? Danisha, you see the board, yeah. Remember, we have one Tiki board. I select this one fantastic Microsoft whiteboard. Everyone saw. What's the problem now? Okay, Jovino dice yes. Okay, Jovino. Okay, entonces I try to association. For example, Sally. That's the first element in the domain. She got A. And what is the symbolic way to indicate that? Well, easy. You put open parenthesis Sally, comma A. And this is like an order pair. And you have two elements, no? The first element is the first component, is the component of the domain, and the second is the range. And you separate by comma each new element actually is a order pair. It's more complicated, no? Because it's association. It's a symbolic way to indicate the association. For example, Paul is the second guy. She got B. Okay. King. She got B again. And Luis. A. Okay. And this new set formed by 1, 2, 3, and 4 order pair is a relation. Okay, association. We can do association in between everything in the real life. For example, when you go to a store and you ask how much is it, you try to associate, for example, one item that you want to buy and the price. The price is the number, the item maybe is a Coca-Cola, or is aguacate or avocado, whatever you want. Okay, there are association between two sets. There are many ways, in mathematics, there are many ways to represent and visualize relations. And we study, we use the formula, we use on the graph, we use on the list, we use on the table. Okay. This is the idea for the relation. Is very, very intuitive to understand this. Relation association between two sets. For example, any people on the world have one birthday. Association. People on the world and one date. Okay? Any question? Relation? No problem with the relation. Relation is a marriage. Wife and husband, no? Relation. Okay. Now a function. This is most complicated to understand. Function is a relation. It's a relation. It's a relation. But a special relation. Pulling off microphone, I hear something. Such that I want to copy the definition. But the definition, in my opinion, is not clear. Such that each value. Hey, I will hear something. Pulling off the microphone, please. Come on, guy, education. This is a complicated day because some student take another test and to say interrupt me. No, I cannot. This is the class now. It's a relation such that each value in domain, remember domain is the name of the first set, is associated, okay, again the verb associate with, and this is the most important moment now, only one, highlight this quotation because it's the most important word in the definition, value in the range. Okay? Okay, let me try to explain again using example because the example is more clear. Theoretical is too heavy. Suppose I have one set I call X, capital X, is formed by element 1, 2, 3, 4. I have another guy called capital Y, que is no number, it's letter. Remember, it's in general, it's object, A, B, C, D. Y ahí declaré que this is the domain, and this is the range. So I want to write down different relation, and you help me to understand si this relation is a function or not. For example, relation 1. Relation 1 is 1, A. Remember, you form the order pair association. You select one element in the domain, you put in the first place, in the first component, and one element in the range, you put in the second component, comma, 2, B, comma, 3, C, and comma, 4, D. Okay, what do you think? Yes or no? Function. According to the definition, yes, it's obvious that yes, because you associate one element in the domain with only one element in the range. This is clear, super clear que es a function. So the answer is yes. Okay, pero be careful because it's confusing and tricky. Let me try another example. Pay attention. Suppose this example. 1, A again, comma, 2, B again, comma, 3, B now, and 4, A. What do you think? Is a function, yes or no? No. Nachisa Flora, say no. Another opinion. Wait a second. Let me go. Okay, this is ugly. This is let me make it on. That was 3, no? Or comma 3, B. And this was 4, no? 4, And the majority of students say, No, because more than, okay. But okay. This is the confusing and tricky part. Okay, the definition is confusing. I know, I understand very well. The definition say only one in the range. To say, and you seek, for example, the complicated part is to be, this is, okay, suppose you associate 2 and 3. Let me use another diagram to understand. You associate with the B. They are repetition B, no? And you associate 1 and 4, you associate with the A. Yes or no? Christian Parra. Okay. Entonces, okay. This is clear. Look, 2 and 3 associate with the B, 1 and 4 associate with the A. But I come back to the definition. Please pay attention. Definition say que es associate with the only one in the range. Remember, this element belong to the range. Yeah, associate only one, B or A. There are no contradiction with the definition. Do you see or no? Do you see or no? I put intentionally because I want you to fail. Yeah. Okay. But I want to say the answer is yes. It is a function again. No perfectly one-to-one function, but it's many-to-one. And remember, the definition say only one in the second set, que is the range. There are no contradiction. The definition work perfectly in this example. I confuse it. I understand. Sorry. Suppose another example: 1, A, comma, 2, B, comma. So cannot be the first A and the 1B. A ver, 1A, and what do you say? Activate the microphone. So you have a question.
No, I was saying, so in other words, what you're saying is whatever's in the range cannot be.
Let me try to explain my lecture, please. Okay. Entonces, now, in this case, relation 3, 1, A, 2, B, 2, C, 3, D. What do you think? Function, yes or no?
No.
Yes. Why no? Why no? What is the problem? I need to understand why no. Because no, yes, this is a yes again. Oino say yes. I hear in the microphone somebody say no. Only one in the range, no? Okay, look at that. In that case, I can see que 2 is only one element in the range is associated with the B and C. Yes or no? And this is the contradiction with the definition. The definition say only one value in the range. So obviously, the answer is no. No function. No function. Definitely no function. Okay, I suppose you understand a little bit. You understand a little bit or no? Not clear, no? Confusing or clear? Okay, don't worry. Let me verification see you understand or no. Okay, relation 4. Suppose relation 4 in another example. Is no domain and range. Is another domain and range. This is well, let me. This is completely different example. Let me erase everything. Don't confuse it with the domain and range of this. It's another. Suppose one relation. Okay, I want to investigate if it's a function or no. You say yes. Okay, the answer I need is yes or no, and what is the domain and what is the range. Okay, this relation is 2, 3, comma, 4, 1. It's another domain, another range. Okay? I need to know 2, 3, -2, and comma out and comma -2, comma 2, -1, and close the curly bracket. The question is a function? Yes or no? It is a function. Yes or no? Question. And my next is what is the domain and what is the range? Okay. For the question number 1, is a function, yes or no? No. No. Jovino dice no. Who say yes? Another student say yes. Okay. Who have the reason? No or yes? And why? I need to understand why.
No, because there's two domains, so it's impossible.
Eso. Very well. Okay, the answer is no. And the reason is clear. Because you associate one element inside the domain, que es 2, and two different values in the range, que es 3 and negative. The answer is no, guys, for this reason. Okay, entonces, what is the domain? Bueno, domain is a set of the element in the first component. This, and this, no? But remember, when you write the set, no repetition is allowed. 2, 4, 3. Actually, we have 4 elements, but it's repeated. Si es repeated, you don't consider. O sea, it's not totally mistake, pero it's not polite, it's not elegant. Que some students write 2, 4, 3, 2, because the rule or the property of the set say que the order is not important and the repetition not necessary. Pero not necessary doesn't mean que es mistake. Okay, and what about range? Well, the range is the value for the second component, que es 3, es 1, es negative 2, and negative 1. Entonces, in that case, no repetition, 3, 1, negative 2, and negative 1. Done, it's the answer. One more example, and you let me know to understand this. Suppose another hypothetical example in which we have... go ahead. Go ahead, question.
Yes, I understand the domain and range. The part I'm confused about is the function. I don't understand it at all.
Okay. Okay. Let me summarize, because maybe I forgot to summarize. Look at me. When you have one-to-one relation, es obvio que es a function. When you have many-to-one, it's obvious que es a function. Why? Because the keyword is one here. And see, you have missed one too many. No, okay. It's not okay. In our specific example, let me come back to the sample. I can see that we have one, que es 2, associated with the many, que es this. And many, one to many, it's not okay. Do you understand now? Do you understand now?
A little
Clear?
bit.
Okay, super. Okay, let me try another example. You help me to understand this complicated theoretical part. Oof. I don't like theoretical part, but I need to study. Suppose this relation is formed by 2, 3, 4, 3, 3, 3. Wow. Oh, no. And 5, negative 1. Okay, the same question. Function yes or no? Function yes or no?
Yes.
Okay. Some people here can say yes, no. Jovino dice no, coño, no.
Yes.
Domain.
Yes.
Okay, yes or no? You need to agree this idea.
Yeah.
And range. Yes. Yes, the reason is you see repetition. Maybe you say, well, maybe no. But the problem is that 2, 4, and 3 is associated with the only one, que is 3. It's a typical many-to-one. Many-to-one. And many-to-one, we have no violation. It's correct, because the problem is 1 in the second set. Entonces, yes, it is. What about domain? Who help me with the domain numbers? 2, 4, 3, and 5, no? And what about range?
3 and negative 1.
Exactly. 3 and negative 1. End the story, guys. Any question? Everyone understand very well? definition for the function, identification of the function. One is an identification of the function when we have the set writing like an ordered pair. It's easy. It's elementary. However, sometimes you need to identification of the function in one more complicated environment. Suppose I have the graph. Suppose I have the graph of the function. Suppose I have the graph of the function. I need to identification. The function. See this graph corresponded with the function or no. Let me try to do 4 example, and you let me know. X, 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 Y, 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 and Y. So we have one graph. It looks like that, like a parabola like that. We have another case, a cubic parabola. After I promise, not today, guy, you need to be familiar with this graph. That every student in college algebra need to know that this is y equal x squared, and this is y equal x cubic. But no, don't worry. After we discussing in detail this idea. Suppose now this graphic look like that. This is arrow indicate us to continue forever in that direction. And suppose what? Suppose a circle we studied the last class. Entonces now to analyze this, we using one test important, super important test, que es called vertical line test. Vertical line test. Vertical line test allow us to determine if the graph is the graph of the function or not. To say you face that, you hypothetically put the vertical line in any position. See this vertical line cross in only one point is the function. Yes. Here, let's try here. Yes, that's the function. Suppose this. Oh no, because crossing 2 points, no function. It's a yes function, no function, and a circle, of course, no. Vertical line test, you apply hypothetical, vertical line, not only one position, you move. Now you try to understand this. I want to put another example. Do you understand the theoretical part? And this is clear. Look at that. Suppose this x value somehow is associated with the 2y. It's a y1 I call, and it's a y2. This is obvious. The 1x is associated with the 2y, y1 and y2. And this is the contradiction for the function. This is one shortcut in which you have the graph in your hand. You can determine if the graph corresponds with the function or not corresponds. Okay. Is there another class? Interrupt me. Okay, guys. I bring one example. Maybe summarize the information we need. Suppose, example, y equal x squared and x equal y squared. Entonces the question is determine if this equation corresponds with the function or not. So determine if this equation corresponds with function or not. I don't know. Entonces one fantastic way to determine this is do the graph of this and do the graph of this, and you apply a vertical line test. Okay? And what is the fantastic way to do the graph in college algebra? I teach you the last time.
Desmos.
Exactly, Desmos. Immediately you open Desmos. By the way, you create the account already or not yet? Tell me the truth, please.
Yes.
Don't lie. Don't be liar.
Yes, I do.
You create. Wow, fantastic. Good, good. When you create, we can share a folder because my folder I transfer to you, and you little by little you learn. If you want to take with me another mathematical called precálculo, you need to master very well Desmos. Desmos is another application, pero bueno, Desmos es important. Okay, entonces I bring for you one application of Desmos. Let me try. What should I do? Well. Okay. Okay. I suppose in that moment you don't see Desmos, no? No? Share. Desmos. Here. Do you see now? Do you see now? Do you see now? Yes. Okay, and the left part, I put the first, que es y equal x squared. I do the graph. Boom. Look at that. It's a parabola. It's a parabola que, by the way, open up. Open up. This is infinity, no? You make a zoom. So you indicate this in the piece of paper. You put the arrow, no? And when you apply the vertical line test, pass or fail? What do you think? Pass or fail? Pass or fail?
Pass.
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 This pass. It's a function. Easy. Pass. The second one, boom. It's like that. When you apply the vertical line test, pass or fail?
Fail.
Fail. End the story, guys. Do you understand very, very well everything? Okay, good. Let me go now to the more new topic inside the function. Que is more interesting, more practice, no? It's about. Go ahead. Question. I don't hear very well. Activate the microphone. You approach it to the laptop. Okay. Repeat the question again, please.
How did you do the vertical line test within Desmos? I have it up right now.
Okay, good question. Look, do you see Mr. Desmos now or not yet? Do you see? Look, it's easy. You create, for example, you put it here, X. Do you see Desmos now or not yet? Yes. You see, no? Okay. You typing X equal whatever. 10. I like 10. I don't know why. Click here. And you create automatically one slider. Can you move like that? Okay? It's fantastic. We're using that. I promise you we're using a slider to analyze transformation for the function. Okay? Okay, don't worry.
Got it.
You got it? Wow, good. Very good. Very good. That's easy. Super easy. Okay, let me move on to the function notation. Very important, very useful. Function notation is the name of the next topic. Function notation. Well, normally you have y equal x squared. That's the common way to write that. However, mentally, you replace y for one notation que is, wow, what the hell is that? Okay, you replace y by f of x equal x squared. So normally, y and f of x is the same thing. It's equivalent. It's the same thing, except this notation, que is the function notation, open new possibility to understand the function. Okay, I want to explain in a few seconds. The function notation is formed by one letter or two letters. We study throughout the course a special function, que the name is this, 3 letters, no more. No Maria. Maria function, no. It's no good name for the function. So one letter que represent the name of the function. Normally in mathematics, the standard is 1 letter, 2 letters, or 3. No more, no 4. Maria is illegal. Okay? Entonces, the name of the function, open parenthesis, okay, suppose h. This is the most common name of the function in mathematics, f, g, h, p, m. One letter que represent the name, you open parenthesis, and inside the parenthesis you put x, que x represent the element of the domain. Entonces, okay, let me finish. Now, let me finish. Okay, the first letter is the name of the function. You assign arbitrary, or it's given. Name. The x represent symbolically the element of the domain. And this parenthesis is a confusing part. Do not represent multiplication. No. It's not multiplication. So, for example, it's very, very stupid.
Professor, we can't see the board. It's frozen on
Oh,
decimal.
sorry, coño. Sorry. I understand now. You're concerned. Okay. Sorry. Okay, I understand now. Okay. Let me know when you see that. Cancel, share screen. Okay. Now it's okay. Now it's okay.
Yes, sir. But
Yes,
can you
but I think
repeat what
sorry, you just say you lost this explanation, right? So I tried to explain that the function notation is formed by one name of the function, normally one letter, two letter, or three letter. You open the parentheses. By the way, these parentheses do not indicate multiplication. No multiplication. And X, que es symbolic indicate element of the domain. So these parentheses do not indicate multiplication. Suppose that we have something, x plus 2. We cannot apply distributive property here. This is a stupid. Okay? Because this is symbolic way of the function notation. I want to explain how you manipulate this. This is completely wrong. Let me erase because it affects my eyes. These parentheses do not indicate multiplication. Okay? Entonces, what is the application for the function notation? Well, let me try example. Example illustrate everything. Suppose elementary, I don't want to complicate your life. Suppose f of x equal 4 minus x squared. This is given. It's given. Entonces, for example, I ask you, for example, evaluate 2. It's easy because the only thing that you should do is replace x for 2. The 4 minus parenthesis 2 squared. Entonces 4 minus 2 squared is 4, but by coincidence it's 0. So when you evaluate any number, suppose 3, 4 minus 3 squared, 4 minus 9, and negative 5. When you evaluate, it's just replace the value inside the parenthesis for x in the expression. And that's it. But this is more because we can do transformations. And we study in detail, not today, next time transformation. But transformation is, for example, si you replace x for negative x, it's the same x, but negative, opposite sign. This is a typical reflection. When you want to do reflection is one kind of transformation. Well, let's do it. You replace x for negative x, look, and the original equation. No x anymore, now minus x. But by coincidence, negative x is squared positive. It doesn't stay only this negative here. It's unbelievable. When you are doing the reflection, the function stays the same. This situation happens in one specific function that we study next time. So we are doing reflection. We are doing another kind of reflection. For example, another reflection. Another reflection is, suppose I put a minus in the front. Okay. This reflection is across the y-axis. X minus x. But this reflection is different. It's across the x-axis. It's y, negative y. So you put it, the sign negative in f of x. And remember, guys, f of x and y is the same thing expressed in different name. Entonces, you put the minus, and the original is this, and this chain completed. It's minus 4 plus x squared. Because it's minus, you can interpret it like a negative 1, a multiplication by everything inside the parenthesis, change the sign. It's another kind of reflection. Okay. You don't understand why now, Professor, what is the reason I need to make a reflection? No. After. This is just introduction to the function notation, and I try to explain a potential application. Another super important application of the function notation is, it's important now, this, not reflection. Forget about reflection for a moment. It's not important. Is in order to find the y-intercept of the any function and the x-intercept of the any. Some students don't remember very well what is the formula to find a y-intercept and what is the formula to find the x-intercept. But it's easy if you apply function notation because you evaluate the function and 0. That's it. This is the formula to find y-intercept. Let's do it in our example. No? Our example, remember, I'll recopy again, is 4 minus x squared. Then is 4 minus 0 squared. Is 4. And the point, by the way, is the point 0,4. If you want, you plot that point. 1, 2, 3, and 4. This point is 0,4. I know that that function have y-intercept at the point 0,4. And what is the formula that the student don't remember very well to find the x-intercept? Well, it's similar. F of x equal to 0. It's the formula to find for finding x-intercept. This is a formula for finding y-intercept. Let's do it in that problem. In that problem, you take 4 minus x squared, you put enforce it to be 0. Oh, in that moment, we have quadratic equation. Let's solve a quadratic equation. For example, I move x squared to the right-hand side or left, whatever. Apply square root both sides. And we have two solutions, no? Okay, it's plus or minus 2. Therefore, we have 2 points, 2,0 and minus 2,0. It's the x-intercept. Let me see, 1, 2, 1, 2. 2 positive, 2,0, and negative 2,0. Oh, my parabola, because it's quadratic, always quadratic is a parabola, up and down in that direction, and cross it the x-axis in 2 and negative 2, and cross it the y-axis in 4. Super, it's an application. The fantastic application of the function notation is always, if we are doing every day from today, find the x-intercept and the y-intercept. Let me try another example of the, do you understand very well the x-intercept and y-intercept? Do you understand or no? No? Confusing? Guys? Help me. No? No complain? No complain. Olga. Okay, Olga, very well. Another example. I want to illustrate another example. Suppose f of x equal absolute value. Wow, absolute value, x plus a. The same idea. Find y-intercept, find x-intercept. I have no idea, but I remember the formula. The professor explained something that using function notation, u of n 0, and f of x equals 0. It's the formula that we're using to find x-intercept and y-intercept. The value 0 is easy. Replace 0 to say absolute value 0 plus a. It's absolute value a, no? Okay. And the point is the point 0, a. Okay, and this is different because always this is no evaluate. This is no plugging in. This is a solving equation. You solve this equation. This is actual value x plus a is equal to 0. How many solutions we have in this equation? How many? How many? 2 solutions. Everyone is agree? Nafisa Flora say 2 solutions, professor. Everyone is agree or disagree? Agree? Ovino Romero, agree. Who more is agree? Agree. Rosalinda, breathing. Well, you are in big trouble. We have only one solution. Remember, when it's 0 on the right-hand side and the equation that involve absolute value, we have only one solution. Because 0 have only one. See, it's a number here, 2, 3, 4, 5. It's different. This is equivalent to say x plus a. We can remove directly the actual value equal to 0. And the answer is -8. And the point is -8, 0. This is the y in a set. And this is the x in a set. And this function. Let me try to do roughly sketch to understand this function. X, Y. I plot this point 0, 0.8. 1, 2, 3, 4, 5, 6, 7, 8. I plot that 0, 0.8. And this is -8. 1, 2, 3, 4, 5, 6, 7, 8. -8, 0. Look like that, this function. Look like a B. Actual value look like a B. But don't worry if you don't understand this, because I explain in detail the function actual value in your moment. Okay, next time we study a library of the most important function that the student can take college algebra need to know by memory. Any other question? No? Function notation. Let me explain what is the typical example that I like put in the test about function notation. It's a little bit complicated. A little bit. Let me try. Using function notation to evaluate this expression. Look at that. Look at that. Look at that. In calculus, some people need to take calculus here or not? Do you have to take? No, okay. Only you take algebra and that's it. Do you need to take? No, nobody?
I do.
Yes, Rosalinda say yes. Rosalinda, what is your major?
It's Claudia and it's business administration.
Yeah. Maybe you need to take business calculus. Okay. Entonces en calculus, there are one quantity que es important. It's called a difference quotient. And the formula somehow involves function notation. Is f and x plus h minus f of x divided by h. It's a formula. Because I promise in the test, you see one example like that. Compute the different quotient of the following function. Let me start for the one easy. X squared minus 5x plus 6. To find that, the formula is a little bit complicated, no? Because the formula I separate in 3 steps. Step 1. You compute that part first. So you compute f and x plus h. I suppose que h is a number, 2, 3, 4, but in general, I put arbitrary h. So the only thing that you should do is replace x for x plus h. Everyone follow me? Pay attention, this is an important question. This question have 10 points in the test. And this second test contains 16 questions. Test 2, 16 questions. And remember, I need to call 911 always, every semester. Okay? I feel no. I feel no because I need to expand this h. You expand this x squared plus 2xh plus h squared. You foil, no? You foil. Let me do quickly here, one corner, to make sure that I did okay or no. X times x, x squared. X times H is XH. H times X is exactly HH organized in this order. And this is H squared. And when you combine letter here and here together, it's X squared plus 2XH plus H squared. It's exactly the same I put here in my memory, no? Minus 5X minus 5H plus 6. Everyone understand this is step one? No. Easy or complicated? Yeah, I understand, professor. Okay. 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 Very well. El eraser for me is not good. Okay. 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 Now let's go to step two. Step two is the top part, the totally top part. Totally top part is subtracting this expression I did before. And just copy H subtracting minus the original. Is f of x. Look at that. This is f of x, the original. When you subtract it, you change the sign. It's x squared plus 5x minus 6. Do you understand this one? I copy the step. I copy the step one again. This was the answer for the step one here. And this is the original. Okay, I change the sign because I am subtracting. Entonces in that moment is important because everything no, but almost everything is canceled. This 6 and this 6 say goodbye. This x squared and this x squared say goodbye. And this 5 and this 5 say goodbye. And it stay only 2xh plus h squared, so this minus 5h, only that. Okay, finally, in the formula, I can see the last step, step 3, is divided by h. Step 3 is divided by h, this expression. Divided by h. And division, polynomial divided by monomial is super easy. Because the only thing you should do is divide one by one separately. This is 2xh divided by h plus h squared divided by h minus 5h divided by h. One more time happen. Okay, this is cancel. Cancel, 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 division, and cancel, and one here. That's what's the final answer. The final answer is 2x plus 1h minus 5. End the story. Final answer. Complicated or easy? Complicated or easy? Complicated. Sorry. This is you understand that this is college algebra. This is no elementary, developmental, little complicated. Okay. Okay. Do you want another example? Normally the example in the test is no big deal. It's similar to this. Or let me try another. In my opinion, it's easier. But we're doing fast. Because you know the step 1, 2, 3. You know? Suppose the function is given is linear function 3x plus 8. And again, I need to find the famous different quotient. Okay, the formula I want to copy again is fx plus h minus f of x divided by h. It's the formula. But the formula somehow involves function notation. Entonces, this is the reason that in this topic or in this question in the test, we need to practice function notation. So you evaluate in h first, x plus h. You replace x for x plus h. And you remove the parentheses, apply distributive property. Now you're subtracting the original. And normally, when you're subtracting the original, a lot of things cancel. Look, minus 3x minus a. Because I copied the original, but opposite sign, minus here. This and this is cancelled. This and this is cancelled. And stay alive only 3h. Finally, divided by h, divided by h, divided by h, sorry, and you cancel, and the answer is just 3. And this give me one idea what is the interpretation of the different quotient. Because in this case, you remember y equal mx plus b in the linear equation, no? And m is 3. One possible interpretation of the different quotient is a slope. It's a slope. And it's a line is a slope of the line, but when it's a curve, is a tangent line in the point. Approximate. This is the idea for the calculus. Differential calculus always computed the tangent line or the secant line because we have 2 points, no? Suppose the curve, we have 2 points. This segment is called H, and we connecting this point and this point by the straight line. And this is not tangent line, but it's secant. Secant line. This is tangent. Tangent torsion 1 point, secant torsion 2 points. This is the idea, approximate the geometric interpretation for the different quotient. But you don't care. When you take calculus, you need to you understand much better. So far, the important is function notation and application specifically in the different quotient. Okay, let me come back again to the domain and range. Another typical question on the test is domain and range. In the test, I give you one graph, one horrible graph that contain any problem that the function maybe have. Maybe we have holes, we have a gap, we have maybe jump, discontinuous. Any situation you have in the function. Let me try one elementary example. Look, suppose I'm going to be using the paint. Click the paint. Okay, come on here. Okay, good. Suppose a function like that. Ooh, arrow. In this case, we have a hole. Suppose this is 0. This is 1. This is 2. So specifically in 2, we have a hole. We continue here. We have here one thing, but I indicate in this symbolic way. This is like a close, and this is open, no? And so this is 3. And suddenly in 4, in between 3 and 4, we have a gap. Nothing, no function. And we have here another hole in blue color. And this continues forever, but in that direction. Ooh, in that direction. This is my function, my weird function. But it's given this graph. So according to the graph, I need to compute domain and range. I want to explain in detail this. Pay attention. Domain, blue color. Range, green color. Remember the definition of the domain. Domain is a set. Is the element, is a set of element, and the first component is x, element x. In order to find the domain graphically, you select arbitrary point, bam, 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 and you projecting this point onto the x-axis. Is the element of the set of element in x in which the function is defined. Define it, not undefined. Undefined is bad guy. Undefined is no good. Okay, undefined. Okay, entonces en conclusion, the assumption que always we are doing, you suppose que the domain is all real number. It's a supposition, except the restrictions. And restrictions are holes, gap, jump discontinuum, asymptote, another thing que we studied throughout the course. Pero es obvio que the domain contain the value of the x in which the function have a value. Suppose here is complete, and 2 is complete out the domain. Okay, here we continue. Taca, taca, you project. So my domain, in my opinion, is, let me highlight in this color, is from negative infinity to 2. And 2 stop, because we have a hole. We indicate the hole like that. And we continue, is from 2 to 3. And 3, no. And 3 we have because this is closed. This is open. Include 3. And between 3 and 4, we have no function. It's totally undefined. No y value. Now in 4, continue forever to positive infinity. This is a, well, let me see. This is a negative infinity. This is positive infinity. What about 4? 4, no, because we have a hole here. So when you write the domain, express it in interval notation. By the way, some people forgot in the last question, the 12 and 11, express the answer, are doing well, but don't write the answer in interval notation. And those are the students que make this mistake, I decrease in 2 points for this situation. Bueno, es from negative infinity to 2, parenthesis, because do not include 2, union, basically we have 1, 2, and 3 p's, from 2 to 3, pero include 3, union, parenthesis 4, infinity. This is the domain. Express it in function of. This is confusing. This is weird. Do you understand? Domain, when you hear about domain, represent X value. I try to using common language. It's X value in which the function have defined. Define means que Y exists. If Y do not exist, it's undefined. It's complete out the domain. The range is a little bit more complicated because the range is the Y. Well, no, not complicated because you're projecting now onto, so at the same point on the curve, you project it onto the Y value. Okay, you project it onto the Y here, exactly onto the Y here, because range is Y. When I suppose that this curve continue forever in both directions, my range start here in negative infinity, start in negative infinity. I don't know what happened exactly here in 2. Okay, maybe this is value not necessarily is 2, I suppose it's 1. So this information is clear given in the test. Now, I don't know, si continue or no. But I know to stop here because in this moment, look, I project here. In this moment, we have no Y. Suppose that this is 2, 1, 2. We have no Y in 3 and 4 and 5. This is the ending here. And from negative infinity, that the range is from negative infinity again. It's a Y value, Y values, in which the function is defined. But okay, here in 1, we have a hole. But unfortunately, we have no hole here and corresponding with the same value. Therefore, this close point fill out the hole. and the answer one stay the same. Bueno, ok, entonces union 1,2, pero more elegant is known as connecting this and this together is minus infinity, 2. Because this is continuous. No, we have no hole here. Do you understand why we don't have hole? Because we have hole in this projection, but we have no hole in this projection. Therefore, we have y value for this case 1. Okay, I don't know exactly, but at this point maybe a 5,1. No? So 1 belongs to the range. Do you understand this idea? It's very, very complicated. Some students don't understand very well. Sorry. I try to, a little bit. Yeah. I try to explain one more time in the review package. Another more complicated example. Okay, in the last part, in the last 15 or 12 minutes we have available is more interesting. It's about domain. We continue working with the domain, but in this case, we compute the domain, only domain, not range. Range is graphically, but domain analytically in the equation. So if one equation is given, let me explain in detail one more time this. Domain is a set of x value in which the function is defined. Entonces, what is the, normally we assume que es all real number, except restriction. And when you have restriction, when we have restriction in two possible conditions, restriction. Okay, when you have division, look at division. Suppose that you have a function, and that function is equivalent division to expression, p divided by q. Well, what happened? The domain SQ must be different to 0 because we cannot divide it by 0. So 5 divided by 0 is division totally illegal, it's undefined. 0 divided by 5, yeah, okay, it's 0. But division by 0 is impossible. And this is one possibility of to be undefined. Division by 0. It's my first possibility. My second possibility is we have a function that contains square root. Because you know that the expression E, capital E, must be greater than or equal to 0, so non-negative. Because you know what happens when it's negative. Because square root negative 25 is imaginary. Phi. And phi is completely out the all real number. Remember, the supposition was all real number. This was all real number. And the imaginary number living in another dimension, que is completely out the real number. Just consider it like a restriction in our graph. And the test number 2, the imaginary is completely a guy living in another planet, not in our planet. And they are combination 1 and 2. For example, it's important to study one combination que es P divided by radical E. P divided by radical is a combination radical and denominator, both together, no? So the restriction is E, expression must be positive. 0 no, because 0 in the denominator is undefined. And negative no, because negative inside the radical is imaginary. Okay, this is the most important restriction. However, I want to complicate your life using combination of this restriction. Okay? Let's start for the, let's do in, I don't know, 1, 2, 3 example. Example 1 of the domain. Example 1 in which I give you equation, you need to investigate domain. It's the idea. So no graphic, no equation. The equation is given. Suppose f of x is equal x plus 4 divided by x squared minus 2x minus 3. Entonces, my question is, find domain. of x. So I can see that this look like similar to this idea. The idea number one, que es division, P and Q. This is division, right? Entonces, I know que the domain is all real number, all real number, all real number, all real number. You can write like that in English if you want. All real number except restriction. Well, except restrictions. And the restrictions, and the restriction, in this case, you found using the expression in the denominator because it's totally illegal. This expression should be zero. So this is, you write like that. No zero, illegal. Satisfy this condition, illegal. You solve this inequality. Now, and the solution for this inequality is the domain of the our function. Okay. Listen to me. This inequality is a little complicated, but the equation is not complicated. Temporary, I want to convert to equation. And this is quadratic equation that you solve in 5 seconds. In this case, I suppose that the best way is by factorization. Because the combination is 3 and 1. No? 3 times 1 is 3. 3 minus 1 is 2. Minus 4. The solution is x equals 3. And the solution is negative 1. This is the solution for the quadratic equation. But remember, actually it's the restrictions. And the restriction is no zero, no zero, no equal, no equal. So what is my answer? What is my final answer? Well, my final answer in English is all real number except the bad guy. And who is the bad guy in that problem? X, not 3. And let me separate. You can separate by comma. But more clear is you put a conjunction and in between, no negative. And it's a fantastic answer. However, I am picky. In the test, maybe I ask you express the answer in interval notation. Okay, interval notation. I don't want that way. That way is not good for me. Not good for me. This is good, but I ask you specific that way. Interval notation. Okay. Let me try. Interval notation is look. This is all real number. This is my entire all real number line. Infinity positive, infinity negative. However, I discovered algebraically here that we have two bad guys. This is 0, 1, 2, 3. Here we have a hole. And in negative 1, we have another hole. Okay? And the rest is okay. So my domain is then that part. This is a hole. That part. This is a hole. And that part. So my domain contains 3 intervals. I highlight in yellow color. The first interval is from negative infinity, comma negative 1. Of course, do not include negative 1. It's a hole. Union, negative 1 to 3. Union 3 to infinity. And this is the elegant answer I want in the test. Interval notation always. Always. Okay, one more example. Everyone follow me or you are lost completely? All right, let me feedback. You understand? You are lost, complicated. I need to call Niagara. Niagara means Olga. Niagara is no. Perdida. Little complicated. Sorry. Call algebra. Okay. 911. Everyone call 911. Sorry. And this is just the beginning. I know. Ha. 911. Okay. In funny way. Of course, I don't call 911. Only one time in my life I call in college algebra in this test the emergency because some students have heart attack when they see the test. But I put in funny way like a joke 911. Entonces some students in the test the question que don't know put call 911. You write directly call 911. In this question call 911. Okay? Okay. Listen to me. This is a process. This is a process. Little by little, you learn. Okay. Listen to me. Some people say, Professor, this is Chinese or Japanese? No. Okay. This is mathematics. This is classic. Everyone need to understand and learn this. And if you want to graduate in one career, in one major, you want to see a lot of more complicated thing in your life. You say, what is the motivation? Can you try? You try to understand, no, little by little. No, too much Chinese, Japanese, no. No Chinese, Japanese. It's mathematical language. Okay, one another example because we have only 3 minutes, but I suppose that we have time to do example 2. Example 2 is suppose that we have a function like that. I call g is square root 3 minus 2x. Again, domain. So I immediately go to the possibility restriction that we have in the problem because I know the domain is all real number except the restriction. You can see, look at that here. Oh, look at this picture. You maybe take a picture of this. When you have radical, the expression inside the radical must be non-negative. This is the thing you need to apply in this example. Okay? What the hell? Okay. Let me go. Let me go down. Let me go down. Let me go down. Okay. So it's easy. You take the expression inside the radical and you enforce it to be non-negative. In this moment, we have inequality. Super easy inequality. And you solve for x. You move 3 to the other side like a minus 3 divided by negative 2 both sides. This is algebra. Remember, when you divide inequality by negative quantity, you have to reverse it, the inequality sign. Lost. Okay, 1.5. Now the domain is the number, okay, less than 1.5, no? Less than 1.5. How you indicate that in the interval notation? Okay, this is infinity, the minus infinity. I suppose the 1.5, this is 0, 1, 2, it's in the middle, 1.5, and it says to the left. And it's to the left, to infinity here. Of course, include the endpoint because it's equal. So it's bracket here. And the answer of the domain is, this is the graphic representation to understand. It's negative infinity, comma, 1.5 or 3/2, depending the fraction of decimal you want, bracket. That was hard or easy? You need to know factorization. You need to know inequality. If you don't know, this is how you pass the test 1. Okay? Okay. Stop. Any question, guys?
Is that the answer?
Absolutely. The answer is a set. Remember, domain is set. The answer is domain is set. The set que contain the x in which the function is defined. It's undefined because it's a square root negative number or division by 0 is totally undefined. Guys, this is no big deal. This is called algebra. Okay? Little by little, we need to learn. Next time, I bring a lot of problems. And then you see one question. Like that. Okay? You have some question? No? Okay, you can leave if you want. Thank you. Okay, Darlene Turtelane is here or no? Darlene Turtelane, are you there? Thank you, thank you, thank you. Pleasure. Okay. Sergio, Minerva,